Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is integrals. In this video, I will be focusing on NCERT solutions for exercise number 9. This is a definite integral problem in which we have to find limit of the integral varying from 0 to 1 for the function x by x square plus 1 dx. In this video, we'll be focusing on a shortcut method of the definite integral in which we change the substitution. I will show you with an example. For example, in this we'll put 1 by x square equal to t. So this implies 2x dx equal to dt. We have x dx here. So we can write x dx equal to dt by 2. So now we have made a substitution with respect to t, and when we solve this integral in the previous occasions, we are going back to putting that we get a answer in t, then we substitute t equal to 1 plus x square and then put the limits and get the answer. But in this process, that is a more lengthy process. In the present video, what we will be doing, we will be changing the limit values with this transformation, and in the final answer we don't bring t to 1 plus x square. Just whatever we have substitution, we get the final answers but with the revised t values. So what is the thing here? When x is 0, so when x equal to 0, in this we put it, t will be equal to 1. So when x equal to 1, here it is given here, when x equal to 1, t will be equal to 1 plus 1, 2. So now we change the limits. We change it like this. Instead of 0 to 1, we put 1 to 2. And x dx is dt by 2. So we can put it like this, 1 by 2 dt by t. And we are getting directly the answer. We don't have to change it back to 1 plus x square. So this is half log t with limits 1 to 2, which is half log 2 minus log 1, but log 1 is 0, so we get answer half log 2. It is important to note that we haven't converted t back to 1 plus x square. In the previous occasion we used to do that. That also can be done. We can change t back to 1 plus x square, then we need not change the limit here. That will keep it 0, 1. But this method is more easy and more better shortcut method. We can call it as a shortcut method in which we change the limits, and when we make the substitution, we don't go back with the substitution values. So in this is also similarly we will do. We'll put t equal to sine phi, t equal to sine phi. So this implies dt equal to cos phi d phi. And when phi equal to 0, this limit will put when phi is 0, t is 0. When phi is equal to pi by 2, here given when phi equal to pi by 2, sine pi by 2 is 1, t equal to 1. So our problem now becomes integrating from 0 to 1 root t d phi is t equal to sine phi, so dt equal to cos phi d phi. So 1 cos phi we will take from here. So this can be written as cos 4 phi into cos phi. So this cos phi d phi will be dt. So we can write dt here. Then we are left with cos 4 phi, that can be written as 1 minus sine square phi the whole square. But sine phi is t, so this can be written as 1 minus t square the whole square. So this integral is now reduced to this value, and we can directly get the values of the integral. We don't have to convert back the t values to sine phi because we already changed the limit values. So this we already discussed in the previous slide. So this can now easily solve. We'll multiply, or first we'll expand this. 0 to 1 root t 1 plus t power 4 minus 2t square dt. Now we multiply each term with root t. So this will be 0 to 1 t power half, we can call it, dt, plus 0 to 1. So half into 4, 4 plus half is 9 by 2. So this we will call t power 9 by 2 dt minus 2 integral 0 to 1 root t into t square. So 2 plus half is 5 by 2 t power 5 by 2 dt. Now this can be easily integrated. You know how to do it. So this will be half t half plus 1 divided by half plus 1. So this will be 2 by 3 t power 3 by 2. This will be plus 2 by 11 t power 11 by 2 minus 2 into 2 by 7 t power 7 by 2, and this will be, limit is from 0 to 1. When we substitute, we get a final answer as 64 by 231. How do we get this? We first put 1 in each t values, then we put minus sign, and then we put 0 in all these places. We will get final answer as this. So in this problem, we need to find integral 0 to 1 sine inverse 2x 1 plus x squared dx. We make a substitution here, x equal to tan theta. We will see why we have made this substitution. Then dx will be equal to sec square theta d theta. So we will replace dx by this quantity. Now we need to change the limits also. So when x is 0, when x is 0, when x is 0, theta is 0. When x is equal to 1, theta equal to pi by 4. Why? When x is 1, tan pi by 4 is, or tan 45 degrees 1. That is why we have put theta equal to pi by 4. So we'll change the limit now from 0 to pi by 4. Why we have put tan theta is, now we make a substitution 2 tan theta by 1 plus tan square theta. That is nothing but sine 2 theta, and sine inverse sine 2 theta is 2 theta. 2 theta, and dx is sec square theta d theta. So we'll solve this now. This is the first function, this is the second function. 2 can be taken outside. So first function into integral of second is tan theta minus differential of first function theta, differential is 1, into integral of sec square theta, which is tan theta. This all will be limit from 0 to pi by 4. So what is this? 2 theta tan theta minus, what is the integral of tan theta is log sec theta, minus 2 log sec theta, 0 to pi by 4. So let us put pi by 4. So this will become pi by 2, and tan pi by 4 is 1. Now we'll put pi by 4 here. So minus 2 log sec pi by 4 is root 2, and when we put 0 here, tan 0 will be 0, this terms will vanish. Let us see it. Yes, this will vanish, and we will be left only with these two terms. What is log root 2? That we can write it as minus 2 log 2 power half. So this can be written as minus 2 into 1 by 2 log 2. So this will cancel. This will be pi by 2 minus log 2. So this is the final answer. So in this problem we will make the substitution x plus t, x plus 2 equal to t square. So dx will be equal to 2t dt. So we will replace dx by 2t dt, and when we will change the limit also, when x equal to 0, when x equal to 0 here. So when x equal to 0, t square will be equal to 2. So t will be equal to square root 2. So when x is equal to 2, here when x is equal to 2, 2 plus 2 is 4. So t will be equal to 2. So we will change the limit. Instead of 0 to 2, we will change it from root 2 to 2. X is t square minus 2, t square minus 2 into root of t square is t dt. Dx is 2t dt. So another t square will come here. Here 2 will come. So we got the expression converted to t, and also limits change of the definite integral. So we got this expression. So we can solve it to root 2 to 2. We will multiply t power 4 minus 2t square dt. What is the integral of t4? T power 5 by 5. So 2t power 5 by 5 minus 2 by 3 t cube. One more 2 is there, so this will be 4. This will be 4 by 3 t cube with limits root 2 to 2. So we will first put 2 in this expression, get a value, then with the negative sign we will substitute with root 2 and get an expression. So the final answer I am just writing 16 root 2 plus 1 divided by 15. So students should get this answer. So in this problem we make a substitution. Cos x equal to t implies minus sin x dx equal to dt. So we will be replacing sin x dx with minus dt and cos x with t. Now we will change the limit also. When x is equal to 0, we put it here. When x is equal to 0, t is equal to 1, and when x equal to pi by 2, this is pi by 2 here. So cos pi by 2 is 0, t is 0. So our problem now changes to 1 to 0 with a minus sign, because minus is here, dt by 1 plus t square. But what is the integral of 1 plus t square is tan inverse t equal to minus tan inverse t. 1 to 0. We'll put 0 here. Tan inverse 0 is 0. Then we change the sign, so this will be plus, and tan inverse 1 is pi by 4. So answer is pi by 4. So in this expression we can be written as minus 1 to 1 dx by, denominator can be written as x plus 1 the whole square plus 2 square. We are trying to write in the form x square plus a square, so that's why we have written this. Now we can make a substitution x plus 1 equal to t. So implies dx equal to dt, and when x equal to minus 1, here when we put x equal to minus 1 here, t will be 0. When x equal to 1, why we are putting x equal to 1? Because limits we are changing, and we put x equal to 1 here, so t will be equal to 2. Now we change the limit from 0 to 2. Dx is dt, denominator x plus 1 is t, so t square plus 2 square, t square plus a square. So it has come in the form. So what is the integral of this? Is half tan inverse t by 2 with limit from 0 to 2. So when you put 2 here in t, this will be 2 by 2 1. Tan inverse 1 is pi by 4 into half is pi by 8, and when we put 0, this term will be 0, so we will get only pi by 8 as the answer. In this problem we make the substitution e power 2x equal to t. I am sorry, 2 power x 2x equal to t. So how do we proceed? Then 2 dx equal to dt. So we will be replacing dx with the dt by 2. And now what we'll do with the other thing? We have to change the limit first. So when x equal to 0, 1. When x is equal to 1 here, we need to get the value of t. When x equal to 1, t will be 2. When x equal to 2, t will be equal to 4. This is the value of t. So we have to change the limit now from, instead of 1 to 2, we have to change it from 2 to 4. So what will be the value of 1 over x? Now we see here 2x equal to t. When x goes down here, that will be 1 over x, that will be 2 by t. So 2 by t minus 2x square. So let us take here square this, 4x square equal to t square. So 2x square we want, 1 over 2x square. So this will be 2 into 2. 2x square will be there, we can bring it down. So 1 over 2x square will be equal to 2 by t square minus 2 by t square e power t dt, and since dx is dt by 2, we have to put 1/2 here. So we can take 2, this 2 we can take outside. So half into 2, 2 to 4, 1 over t minus 1 over t square e power t dt. Now we see that a function with e power t and a function f and its derivative is given, the answer can be straightforward. That is e power t by t. This is the solution for this with limit changing from 2 to 4. So let us put 4 here. So e power 4 by 4 minus e power 2 by 2. So this is the answer. So in this problem we make a substitution. Or first what we will do, we will take x power 3 outside. So this we can write it like x power 3. We are simplifying this. X power 3 we can take it outside. When it comes outside we have to bring 1 by 3 also. So this will be x by x cube minus 1 power 1 by 3 divided by x power 4. But what is this? This will be x, and when it cuts with this, we'll get x cube in the denominator. Similarly, let us change the limits, but first, okay, we'll write it again. This expression, what has happened? 1 by 3 to 1. So this expression is 1 over x square. x by x cube is 1 over x square minus 1 power 1 by 3 dx by x cube. So we have simplified this expression into this. Now we will make the substitution. Let 1 by x square minus 1 equal to t. Then what is the derivative of this? Minus 2 by x cube dx equal to dt. We want dx by x cube, so dx by x cube will be equal to minus half dt. So we will make that substitution. And also we need to change the limit. So when x equal to 1 by 3, we put it here. What happens? T will be 8. When x equal to 1, so t will be 0. So we have to change the limits now. Instead of 1 by 3 to 1, we have to make it to 8 and 0. So we'll write minus half first from here. Then dt will be coming. Then this expression is t. So t power 1 by 3 dt. So how do we proceed now? What is the integral of t power 1 by 3 is 3 by 4 into t power 4 by 3. Correct? So we can write minus half into 3 by 4 t power 4 by 3. 4 by 3 with limit ranging from 8 to 0. So this will be minus 3 by 8 into 8 power 4 by 3. Sorry, this is 0. This is 0. Limit varying from 8 to 0. So we can put 0. This will become 0. So this will be 3 by 8. When we put here, the sign will change. 3 by 8 into 8 power 4 by 3. What is 8 power 4 by 3? 3 by 8. 8 is 2 cube power 4 by 3. This will get cancelled. 2 power 4 is 16. 3 by 8 into 16, which is 6. The correct option is A. In this problem, we are given a function f of x as this. We need to find f dash x. So we need to find f of x by first doing this integration process. So let us do this by parts. So first function into integral of second function, which is sin t is minus cos t, minus integral differential of first function t is 1, again minus cos t dt. So this is minus t cos t, and integral of cos t sin t plus sin t with limits varying from 0 to x. It is given here 0 to x. So we will first put, so this is f of x. So f of x is, first we will put x. This will be sin x minus x cos x. When we put 0, sin 0 will be 0. This also will vanish. So we will get only sin x minus x cos x. Let us find f dash x. Sin x differentiation is cos x. This by parts will do. Minus x into cos x differentiation is minus sin x minus cos x into derivative of x is 1. So this will get cancelled. We will be left with x sin x. So we will search for the option, yeah, B is correct. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.